All right, here's an FRQ from 1984. I like the book. I wasn't born yet, and neither were you guys. All right, so we have a continuous function. We have some values of f, good to know, and we have a table with properties of f prime and f double prime. And we're looking for the x-coordinates of all absolute maximum and absolute minimum points of f. So if we kind of look at the behavior of f prime, let's make our own little table. So let's see, we have -3, -1, 1, and 3. So looking at just the derivative here, first derivative, from -3 to -1, it's positive. From -1 to 1, negative. 1 to 3, negative. So, looking for our absolute maximum, since the derivative was greater than 0 from -3 to -1, only on -3 to -1, f is increasing on -3 to -1, and then starts decreasing at -1, so f must have an absolute maximum at x equals -1. Let's write this down. So since f prime is greater than 0 only on the interval from -3 to -1, f is increasing on -3 to -1. Therefore, the absolute maximum of f must occur at x equals -1. All right, that's the absolute maximum. Let's think about absolute minimum. So it increases starting at -3, so because the f prime is positive. So f increases from -3 to -1 and decreases from -1 to 3. So our options for our absolute minimum are x equals -3. Basically, we're looking at our endpoints. So it starts increasing, so x equals -3, or x equals 3. That's when it is decreasing and stops decreasing. And so now, fortunately, we have some information. We know f of -3 is 4, and f of 3 is 1. So since f of -3 equals 4, and f of 3 equals 1, f of 3 is less than f of -3, because 1 is less than 4. So f has an absolute minimum at x equals 3. Part B, x-coordinates of all points of inflection. So points of inflection occur where the second derivative changes sign. So we're really only looking here. So let's see, it's positive, not existing, still positive, 0, negative. So it looks like this is the only spot where f double prime changes signs. It goes from positive to negative. So f double prime of x changes signs, goes from positive to negative, at x equals 1. So f of x, or just f, has a point of inflection at x equals 1. Part C, sketching a graph. This is always the kind of interesting part for at least me. You guys know my graph skills are less than awesome. All right, let's do it. So make a coordinate plane. Let's see, we have -3 is where we start, -2, -1. That part's terrible. Let's try that again. You guys are probably better, huh? Let's try this one. -1, -2, -3. That's better. 1, 2, 3. Let's see, what do we know? We know that f of -3 is 4. So there's a point. And we know that f of 3 is 1. So there's another one. Okay. So we have our point. It looks like we're going to be increasing because f prime is positive to -1. So we'll increase to -1. The derivative doesn't exist at x equals -1, so let's make it kind of a cusp right there, or a corner, I guess. And then let's see what happens. Then it will be decreasing all the way until that endpoint. Lovely.